Hello, welcome to Ekidel, where we train future civil and structural engineers. My name is Fashe Ochet. Today, we want to touch the aspect that is at times it gives some protastructure engineers, some concerns, in the sense that this aspect I want to talk about is very, very vital. If you are a protastructure user, you know that at times you normally, talk about it. We cannot do without talking about it, isn't it? And that's issue of our links failing. Is that okay? Issue of what? Link failing. So we want to discuss, to go straight to the point, we want to discuss on this matter about link today. Now, can I ignore my link that failed in Protastructure? I will say yes, and I will also say no. Yes, I'm going to explain it, and no, I'm also going to explain it. Things that you will see that will make you to ignore it and move ahead, I'm going to be explaining them. And things you will see that will make you not to ignore it and make sure it passes the design, all of them, I'm going to be explaining it in this video. That is why it's very important to sit tight, and before then, make sure you click on the like button and subscribe if this is your first time, because it's something like a form of a class teaching now concerning this particular link when your link failed in Protastructure. Is that okay? Because at times you might see, for example, if you look at this beam now, you can see that this place it might pass the design, everything passes, but this particular one will not pass. Is that okay? And why it's not passing is because of what? Because of link, which will require to increase the depth, things like that, if you are used to Protastructure, isn't it? All right, that is fine. So I'm going to be explaining when to ignore or when to leave it, to make sure what you still go further in either increasing the depth or the width, or in terms of torsion or whatever. So all of them I'm going to be explaining in this video. So sit tight, as I said, as we proceed into the action. But before then, I want to say, please don't forget to click on a like button or also subscribe if this is your first time. Is that because there are many people who are using Protastructure that would like to have this knowledge. So for the sake of others, please, each of you that are watching this video, please hit on the like button and also subscribe if this is your first time. All right, within the country, outside the country, people are waiting for this kind of a video. Is that okay? All right, now let's now start. Also, before we start, sorry, it's very important I bring up this. We also have a steel design mentorship, whereby you can see that we have dealt a lot with concrete using Protastructure. So when it comes to steel now, this year we want to really deal with steel design. When it comes to steel design, we want to deal with it just as God has helped us in terms of concrete. You can bear us witness that in terms of using Protastructure to design anything concrete structure, God has really helped us and is still helping us. Is that okay? So if you want to also be part of that, very soon we are going to release the link in which we are going to do a video that will direct you on how to join that particular group, because it's different from from Ekidel. Is that okay? It's different from Ekidel, and the software we are going to be using is not going to be Protastructure. So all of those things we are going to is going to come up. So it's very important you click on like button so that others will be aware of this, and also subscribe so that by the time we release that video, they'll be notified also and then join. Is that okay? So that we can move together. As you are good on concrete, it's very good. You are also good on steel when it comes to steel. Is that okay? Not that you get a structure on steel and now be referring it. Is that okay? All right. So that is it. So that I can make you a complete engineer. All right. Having explained all of this, let's now start this. So if I look at this one now, this is a beam 43. This is beam 43 and story 2, beam 43. So that's one that is failing. So let's first of all see if what is happening there. Is that okay? What is happening there? All right. So I'll come to my design. Let's go to let me bring up this one first. Okay, no. Where is it? Design and my beam. Let it come up. Okay, let me activate something first. Where is it? Okay, this one, then my axis, let them come up, then come to design and come to this not column, sorry, it's not column, come, let me close it. We are going for beam, we are dealing with beam. All right, so let's go to story 2. So you can see in this story 2, can you see story 2 beam for 23, 24, and this, they are the one that is what that is failing. This particular beam here is the one failing. Is that okay? So I'll click on OK, and if you look at it, first of all, if you look at it, it's showing me 0 point. My utilization ratio is showing me 0.84, which means in terms of utilization ratio, this one is satisfied. Now, why this one is not satisfied is as a result of that red that we are seeing. And what's the cause of this red is what is our link. Is that okay? Which we are going to be seeing now. Let me click on it on interactive design, and you can see. No problem. Let's see. Let's move on. Let's wait for it. All right. So I'll now click on OK, which is yes. So now, as we can see this particular place now, let's hold on. Correct. So if you look at this particular place, this one here, first of all, I'm going to in my select bar and use 5, pattern 5. First of all, because there are some things I want to see before I will know whether I'm going to ignore it or not. Is that okay? All right. So I'll come here now, then provide a bar around this place. That is fine. Now if you look at it, apart from how to do interactive design to do your settings, we have done a lot of video on that, so you can watch that on watch those ones on our YouTube. Is that okay? But what our concentration is what on link failure, either to ignore it or never to ignore it. All right. So now coming to this place now, if you look at it, if you look at this length of this beam, can you see all of them? They are all passing. And if you now come to this place now, you now discover that this place, despite the very short distance, term of length, this is about 300. So if you look at it, that is more than 300 or not. So this particular place now, how are we going to handle it? Looking at it, and if you now look at the depth also, can you see the depth? I purposely do this so that I'll be able to explain. Can you see the depth? At 950, 975 is still failing. Looking at the span, and also looking at this particular place at 2 point something meters, let's just say approximately 2.1 or 2.1 something or 2. So now meters, so you can now see depth 975 meters. Why this other one that's 750 whatever. All right, but since our concentration is here, I'm going to be dwell on this aspect alone. Now looking at this particular place, if you can see that it's not justifiable for us to have a length of 300 and be having a beam of what? A beam depth of 975. Am I correct? That is fine. And if you now look at this place also, all others are passing, but this place is not passing. And that is what is making us what? To keep on increasing. Whereas it's not reasonable if you look at it. Now, how will I know that I can ignore this? Or let me just use the word, I will not ignore it. Let me first of all handle the aspect of not ignoring. When your link is failing, how will I know that I will ignore it or not? Number one, we are not going to ignore it. If, please listen now, we are not going to ignore it, this link failing, if, number one, this particular place is showing you already, this you can see that it's link, is showing you red, good and fine. Now there are other things to confirm it. You will not ignore it if this particular place is showing you red. Anything here around this place is showing you red, automatically you cannot ignore it. That's number one. Two, if the value here is what is less than 100, also you cannot ignore it. That's number two. Number three, if the whole of this place anywhere here, the value here is less than 20, even though it's showing you red, it's less than 20. That's number three, you cannot ignore it. Number four, above all, if you check your deflection, and the deflection is showing you red, you cannot ignore it, one. And if you also check your deflection here, and the difference between this one here and this one here is just around 1, at that point you cannot also ignore it. You cannot ignore it. That is very, very important. You cannot ignore it. So looking at all of these conditions I've mentioned from this place, this particular place, and your deflection, if you check all of them, couple with your utilization ratio. If your utilization ratio is giving you 1 plus, not instead of 0 plus, 0 something, and giving you 1 something or 1, you cannot also ignore it. If you look at everything I have mentioned now, and that is the condition of your own. Excuse me, you cannot ignore it. It's either you increase the depth or you increase the width. Any of the two, you have to do that. But now, when it comes to that aspect, I believe it's clear. Now, coming to the aspect of yes, you can ignore it. What are the conditions that will make you to ignore it? I'm going to be explaining them critically now. That is the aspect. Now, you can ignore it. Number one, let me start all over. If you look at my utilization ratio, it's showing me 0 point. Am I correct? Even though this one is showing you red. Am I correct? This is less than what? Less than 1. Number one. I'll come to my utilization ratio. Let's forget about this one first. I'll click on OK. Now, once it comes up, let's wait for it. Come on. All right. I'll click on yes. Now, I say that utilization ratio is less than 1, which is 0.84. So now, coming to this place now. I'll now check. Let me first of all make it a straight reinforcement. Let me provide reinforcement here. Let's finish. Please take your time to watch this video and understand it very well. Let me provide my reinforcement here. Let's say I'm providing this. Now, coming to this place now, for me to say yes, I can ignore my link failing. This link failing. Now, what I'm going to be explaining is beyond just here. So please watch this video very well. Now, coming to this place now, for approval number 1 is that of utilization ratio. Number 1 is less than 1. Coming to this place also, you can see that this place there is no red. And this place is more than 100. In fact, if you look at it, it's far more than 100, isn't it? Which ideally, we're supposed to reduce it. Because if you look at this place value here, this is 771.8184 and 603.17, which is far more than 100, which ideally we can reduce it, the depth of this beam. That's number 1. So it's far more than 100, and also it's not showing rest. That's number 1. That's all. Number 2. Now coming to this place now, no value here is showing red, and even though it's showing red, but the value is more than 20, it's still okay. That's approval number 2 or number 3, and depending on how you are counting it. No, now if you now look at the deflection here, which you know that our beam is most of the times about deflection and what do we call it? Torsion and all of that. So now, if you now look at my utilization, my deflection, my beam that's supposed to fail in terms of deflection have passed. All other ones have passed. This one also have passed. Now, when this one have passed, this particular one have passed, you can see 0.7 less than what? 80.15. And if you look at the difference between them, is far more than 5. Am I correct? So it's far more than what? More than 5. Without even any pressing calculator, it's far more than 5. Am I correct? All right. So since it's far more than 5, that is perfect. Now, it has proven to me that in this particular beam, there's no deflection. Even though it's showing me link failure, because this link at times makes us to increase our beam depth unnecessarily. Are we together? Because these are SS check in terms of what? When it comes to Protastructure. Is that okay? So, and I've explained already when you cannot ignore it. I've explained all those reasons why you cannot ignore it. Now I'm on the aspect explaining the reasons why you can ignore it. Please don't be confused. All right. So now, if you now look at everything here now, it shows that here this particular beam is very okay, but link is the issue. So how will you now know final approval that yes, you can ignore this this particular beam? Sorry, this particular link. How will you now know that yes, you can ignore it and move on? Even though clients want to see that everything pass. For the sake of that, we can just increase everything to just to make sure that what everything pass is showing green. But you know that this particular beam, even at less depth, it is still okay, despite that this place is showing us red. Is that okay? All right, that's fine. Now, coming to this place now, I will now go to the final approval to now know that yes, this beam can be ignored. Sorry, this particular link can be ignored and move on, and even still reduce this depth. Now, there's something we call VED and what? VRG. According to Iroko 2, what does this place means? This VED. This VED is your design shear force. This VED is your design shear force. And this design shear force, what is it all about? It is the factored shear force acting on the beam from your load. I repeat, is the factored shear force acting on the beam from your load. That's G plus Q. So this particular VED, as I said, that is a design shear force, just like your calculated shear force now. The value, because based on the loading, what is the shear force value? What is this shear force on your beam based on the load, based on your calculation? What is the shear force, which is your designed shear force? Just like when you are designing what do you call it, beam, you will say what? You say what do you call it? Area is it area calculated and area provided, something like that. So the same thing is applicable here. So this one is at area calculated. Let me use that word. Or this time around, shear force calculated. So this VED, according to IDO code 2, is talking about what? Your design shear force. That is this particular one, which means the shear force gotten from your what? Your calculation, from your calculation, which is what? The factor shear force acting on what? On your beam from the load. If that is clear, let's keep it aside. As I said, in a late term language, is your calculated shear force that you are expecting your beam to carry to be able to withstand. Is your calculated shear force that you are expecting your beam to be able to withstand. Now, why this other part, this VRD max, I say VRD max, same thing according to Euro code, this VRD means the maximum shear resistance of concrete truss. This particular one, this VRD, is the maximum shear resistance of concrete truss, which means that this particular value here, this particular VRD, is the capacity or is the absolute maximum shear force the beam can carry. Can you see now? This one is the calculated one. This is what the beam can carry. For example, this calculated one, we are getting 80. This is calculated one. They're coming to the beam. What, based on this our design now, what can it carry? Can it carry this one or more or not? These are the things you need to now compare now. Which means that, as I said, this VRD is your what? Is your maximum shear resistance of concrete. So in a layman language, or to break it down, it is the absolute maximum shear force the beam can what? Can carry. Is that okay? Now, we now go ahead, which then means now tell us, it then means that let me come to this place now and type, which then means that my VED, for me to be sure, this my VED must be less than VRD. I don't know if you're getting it. So the moment my VED is, you already know the meaning of VED and what a VRD stands for. So the moment my VED is less than VRD, automatically my shear is okay, the beam is okay. But the moment my VED is more than VRD, automatically I have no option than to still go ahead and increase that beam. Are we together now? So which now take us back to this place now. To confirm this one now, my VED must be less than VRD. But if I now check my VED and I now discover that my VED is greater than what they call it, VRD, even though all of these places are showing okay, I must still go ahead. I must still go ahead to do what? To increase, either to still go ahead and increase the depth or the width. Are we together now? So this is how you go about it. Now the question now is, how do I now locate all of this in Protastructure? We are going to go there. So now for me to go there now, I can now come here now. Let me close this. Now it's in this place. So let me remove, since I'm considering this, don't forget we are talking about what? Story 2. This is story 2, beam 43, 44. Is that okay? Beam 43, 44 and the rest. Is that okay? All right. Because if I look at this plate that is failing, let's go back. If I look at this plate that is failing, come on. In case up to now you have not still clicked on the like button, I want to say, looking at this video, it's very important to hit on the like button and also subscribe if this is your first time, because many are there to learn this particular aspect we are discussing. If you love others, please do them a favor and also do us a favor by clicking on the like button. Is that okay? All right, and subscribe if this is your first time. Okay. The beam that is failing, if you look at it, beam 43. Can you see now? Story 2, beam 43. That's what we are considering, isn't it? Now, having explained all of this now, I'll come here, remove print mark, remove a print mark. That's all this print. I want to concentrate on this. So I'll come here now. And once I come here now, I'll come to my beam capacity report. Can you see it now? Beam capacity report. Is that okay? This beam capacity report, I'm going to click on it now. Is that okay? I'll now click on it. All right. So as I've clicked on it, you can now see this that brought up this okay. Now this place now, I'll now click on what? On OK. Is that okay? You now click on OK and wait for it. It's moving. So you can now see that it has brought us here. So you can now see that this particular, as we click on it, it has brought us here. So let's now begin now. When it comes to, this is the heading now. This is the heading. You can see the heading here. You can see them here. Now, how do you now know, identify which one is VED and VRD? Now, according to Eurocode, your VED is the same thing as what? VD. Are we together now? Based on Eurocode, your VED is also seen as what? And VED, based on Eurocode, is seen as what? As a VD in Protastructure. So this VD is also stand for the VED in Eurocode. Now, based on this, we are seeing your VED. Can you see VED, which is what? Which is VD in Protastructure, in Eurocode, in this software Protastructure now. Now, is this that's your VRD? You can see this VR. Can you see it now? This VR. So now the first value here tells us our VED, which is VD. In this case now is VD, and this other one here, this one here stand for what? VRD. Why this one stand for what? For your VED. Is that okay? Having explained these two now, let's now locate that particular beam. Let's now locate that particular beam in this case. Is that okay? So don't forget, we are on this place, in this aspect. I think I've explained enough in terms of this. So now, I'll now begin to go. You can see where my cursor is here now. I'll begin to go straight and be scrolling down. Let's be going down. You see, it's still falling in the same place. It's still falling. So let's be looking at story 2. Story 2 beam 43. We are seeing story 1. We are seeing story 1. You can see I'm still there. Let's be moving. Let's be moving. Okay, so we are in story 2 now. We have entered story 2. So let's see. You can see my cursor. We are still going straight. Story 2 beam 43. Yes, I think we are getting there. I think it's this place. Let's trace it. Yes, can you see? Story 2 beam 43. Can you see it now? As we are saying it, can you see? And if you trace it to the end, you can see it's less than 3. Our value here is what? It's less than 3, which is still okay. It's under approval. So now, coming to this place now, talking about VED, which is this place now, you can see that my VED is 71 point what? 71 point, what they call it, 7. Is that okay? 71.7. And my VRD is 376.3. Which is farmer. Maybe I think this should be the right hand side. Now the left hand side, can you see 74? I think this should be the right hand side if you trace it up. So this 74 now, 74.1 VED. Can you see which is VD? Now it's less than 376.3 VRD. Can you see now? So looking at this one now, my shell link is still perfectly okay. Despite that in that side, it's showing us what? It's showing us red. And above all, if I now trace it to this place, can you see the value I'm getting here is less than 3. So can you see it now? So it's when you have compared all of these, but assuming we are coming here now, we are now seeing that this 71, instead of this 71, we are seeing, instead of this 71.7, we are seeing 376.3, where the 71 is. And where we are seeing 376.3, we are now seeing 71. Automatically, you have to go back and increase that depth or the width and make sure it passes the design. But in this case, that vice versa, you can see that VED is what is less than VRD, which coupled with all those explanation I've made here, that everything are intact. Looking at that place of extra AS is showing us none of them is what? None of them is less than 100. And they are far more than 100, and none of them is showing red. And this place, the condition I've explained initially, and also by deflection. Couple, if you have gotten all of this all together, you have compared everything I have said, excuse me, it is then you can now say this can be ignored. So looking at this one now, that's why it's showing red, and from I explain, this one I can't go further to increase it, rather I can rather reduce it. Is that okay? Reduce this and see, compare my this place and check this place and check my deflection, and also compare it with that of my utilization ratio and all of that. Is that okay? And go back to that place and confirm it. Is that okay? So this is how you go about your link when it fails, to know either you are going to ignore it or you are not going to ignore it. Is that okay? So thank you very much. Till I see you next time in our next video. Each day that breaks, we try our best from Ekide to see that we bring up new things that are bringing challenge to all engineers when it comes to structural design. Thank you so much. Till I see you next time in our next video. I want to say bye. Please click on like button and subscribe if this is your first time. Thank you.